Don't wait, we're so behind. Yes. This would be, how many days are we going to?
A lot of stories.
Miss McGee, what?
He's a rat on baby.
No, that was just one of them.
Baby, wow. Well, he did tell you.
Did it not post?
I just heard on his written test and the other one. I was really good.
All right, polynomial, is it working, Alex? Thank you. All right, polynomial inequalities. So maybe I have something if you do not know. I'm going to start easy. I'm going to start with a quadratic. Oh, that's not equal. Equal would not be. Solve that.
How do you solve that?
How do you solve that? Okay, yes, but what did you say, Hannah?
Is today the first day of March?
Okay, so if I treat the sign like an equal sign, let's think about this for just a second, about what this means. First of all, if I graph this, not even taking the inequality part into consideration, but just this, if I were to graph that, what does it look like?
Yep.
It's a quadratic, right? Opening up or down? Up. Above or below the x-axis is the vertex? Below, right? It's been shifted down some. So I'm not real sure where it is. I don't have my opposite b over 2a negative. It's going to be negative somewhere over here below, something like that. You absolutely can find the zeros on that, but I guess what I'm getting to is, what am I asking you whenever I ask you this? Is what bigger than 0? Keep going with that. The equation, the graph, what does it mean for the graph to be bigger than 0? That's what we're looking for. Good job. I'll get you a sticker because you don't like
You gotta give her
so this is saying, because it's greater than, this is saying where is it above the x-axis. So I wanted you to understand what it was we were looking for, so that you understand when we find this, how we're finding it, what we're doing. So Davis then said, but we could find the zeros of this because that's where it's changing from above or below, right? Here and here, those 2 points. So this side of that 0, this is all greater than 0. This is all less than 0, and then this is greater than 0 again. Do you agree? Okay, so you don't have to graph it every time, but I really want you to wrap your brain around what we're finding algebraically, because I find that it helps you to understand what's going on. So the first step we're going to do is we're going to find the zeros. We're going to do exactly what y'all said, where we treat it like an equation instead of an inequality, and we're going to find its zeros. So how do I find the zeros of a polynomial? I factor, right? So if x squared plus 5x plus, minus 6 equals 0, factor that. X minus 1, x plus 6. My graph is way, way off. It's completely wrong. Don't look at that. That's embarrassing. Because it's actually more like this. But anyway, okay. Point being here, my zeros are at x equals 1 and x equals negative 6. Do you all agree? 1 and 1, 2, 3, 4, 5, 6. I know it opens up. So my graph is. I know. No.
I'm so sorry.
Thank you. There we go. Trying to rush it. No, I'm trying to rush it too much. All right, I'm gonna slow down. So now the question is, what happens on either side? So I've got the graph, but what if I didn't have that graph? What if I just take that away? And algebraically, I wanted to know, well, where is it positive and where is it negative? So we're going to do what we do in calculus all the time. I call this a sign analysis chart because it tells me what's going on, okay? So I'm going to make a little number line. I'm going to put these on here because I know these are the only two places that it's crossing the x-axis, right? So anywhere left of -6 has the same sign, in between -6 and 1 has the same sign, and bigger than 1 has the same sign. So my question is, what? Right.
Within that section.
Within that interval.
So not all together.
No, from Brenda.
No.
So like less than 6 is all.
So negative infinity to -6 is either going to be all positive or all negative. -6 to 1 is either going to be all positive or all negative, and 1 to infinity is either going to be all positive or all negative. So all I have to do is pick one test point, we'll call it, to see what's going on. So smaller than -6. You can plug into this equation, or you can plug in here. It doesn't matter. I tend to plug into the factored one because it's a little easier. I don't need an exact value. I just need to know if I plug in something smaller than -6, maybe -7, am I going to get a positive or a negative number? Okay. So let's say even -7. -7 minus 1 is a negative number, right? So I got a negative times -7 plus 6 is another negative. What's a negative times a negative? So this interval's positive.
So what do you think?
Somewhere smaller than 6 for this interval right here.
Without right. So the zeros are always
We're answering the question. Look, I asked, where is this function bigger than 0? I'm finding all the places it's bigger than 0 right now. But to do that, I have to look at, Zeros are potentially, unless it's got an even multiplicity and it balances and it doesn't change signs there. So I have to test it. All right, so between -6 and 1, give me an easy number between -6 and 1. 0. If I come 0 into this factored equation, 0 minus 1 is a negative. 0 plus 6 is a positive. What's a negative times a positive? Negative.
We got one before it on this side, one in the middle, and one on the right.
In the middle, or within each interval, you have to do one. Depends on how many zeros you have. How about here? Positive again, because I'll have a positive times a positive, which is a positive. So now go back and answer the question. The question was, where is the function positive? Well, look, here and here. That's exactly right. So where does this happen? From negative infinity to -6, and then from 1 to infinity. Yep. Okay. Now, this obviously gets harder because depending on, this was a quadratic, it only had 2 zeros, and it was easily factorable. But we get into everything of what if it's a polynomial and it's not easy to factor. PRZs come into play. I might have to quadratic formula something. I might have to do,
But you can't have like an imaginary.
if you get an imaginary as a 0, we're not putting that on here because we're not graphing imaginaries, right? And at the end of the day, go ahead. What? Oh, they don't exist. So at the end of the day, if you graph it on your calculator, you can look. Your interval should include everywhere that it's above the axis if it's greater than. If it's less than, then everywhere it's below. Y'all want to do one more? What? You don't know how PRZ? I think all of yours will be able to. No.
What was the steps to that? You said one, and then just forgot all the steps.
I did. I got off the steps. Sorry. I'm going to give you a sheet that's got them on there. I'm going to give you a sheet that's got all right.
I can make that joke.
And you can just plain splash it. You also need to.
The original problem you wrote wrong. I thought you wrote it wrong after you factored it. That's even more embarrassing than me.
No, I taught it wrong in calculus. I'm teaching it right here. I just wrote the problem wrong. No wonder it wouldn't factor. Well, you see what I was doing? I was looking at the zeros on this graph going, but I know it crosses there. Why is it not dividing right? Oh my gosh. What a day.
Hey, who had that on their bingo card for this one?
What are you talking about?
I have.
Let's skip down to number 2. No, not number 2. Let's do number 8 on the back. Number 8. I want to do one that doesn't slash. Well, then finish working it on your own. Okay. That other one will slash and factor beautifully, and it's nice, and it's not. Test your intervals on the thing. What did you get whenever it factored? Give me the fully factored. Sit down, Logan. We're not. They just wanted me to. That should be your fully factored version of that one. Which means no. 0, 1, -1, and -3. Logan. Move away from Liza. She did nothing to deserve you to be sitting beside her. Logan.
I'm just doing something with my best buddy's specialty.
All right, I'm going to come back and test this lesson because I really want to do one with you that's on your homework that you're going to have to work through. All right, here we go. Factor this fully. What happens? You have to PRZ it, right? All right, so try it. All right, so now, listen, what'd you get for a PRZ to try? 7 or 1. I'll try 1, that sounds better. 2, -13, -10, 21. 2, 2, -11, -11, -21, 21. You were supposed to already do this. Does that factor? What multiplies to -42x squared but adds to -11x? So now I have, multiply the first and the last together. Plus 3x minus 21 slash. All right, so I got x minus 1 times. I can take 2x out of these first two. I can take 3 out of those last two, and it leaves me with x minus 7. All right, so now these are my zeros, yes?
No.
Say yes, because those are.
Actually, zeros are 1. Oh, negative 2.
Yeah, that's you right there, big dog.
All right, so I find the zero. So I got x equals 1, negative 3 over 2, and 7. So let's put them on the number line and let's see what happens. I've got negative 3 over 2, 1, and 7. Okay, test your intervals. Test them, Mark said go. All right, so what am I plugging into? I'm plugging back in. I would go with the factored form. Because remember when you talked about those times you wouldn't have a calculator? Yeah. All right, so if I'm smaller than negative 3 over 2, so maybe I am negative 4. If I put negative 4 in, look, I'm multiplying 3 things together. Negative 4 minus 1, is that positive or negative? Negative. Negative 4 times 2 plus 3, positive or negative? That's negative 8 plus 3. That's going to give me a negative. Negative 4 minus 7, that's another. What happens when you multiply 3 negatives together? It's a negative. Yes. Yes. Now let's try 0 plugging in here. 0 minus 1 is 0 times 2 plus 3 is 0 minus 7 is a negative times a positive times a negative is a positive. Between 1 and 7, maybe 2? A negative times a positive times a negative is, yeah, the 2 negatives make a positive, and then you multiply it to a positive. Now, if you get confused and you want to put the number in and actually plug it in and see what you get, you shouldn't get 0 for any of them because you found all the zeros already. Then you did something wrong. Yeah, you did. Oh, then you didn't do something wrong. You won't get 0 if you did it right. All right, if I put in 2, let's say 2. Noah.
You can put in 3 if you want.
Okay, put in 3. Tell me what you get. A what?
You get a
Positive. Okay. Which would give you a negative. Bigger than 7. What do you get? 10. What do you get? Which is it safe to say that these are always going to alternate? No. No, because what if you had a graph that did something like this? And it bounced right there. Then what I'd get these intervals, but I'd have positive, negative, negative. So don't always assume that it goes alternates. All right, so what did it ask me for? It asked me for all the negative intervals, right? Less than or equal to, notice the sign under here, that means I'm going to be using brackets instead of parentheses this time. Yeah. You can by the multiplicity, that's exactly right. All right, so give me the negative intervals. This time it's a bracket. Why is it a bracket this time? That's right. Infinities always get parentheses. Because it's less than or equal to. How about the other positive, negative interval?
Why are you doing it?
Because it said less than or equal to 0. Seven to infinity is positive. We're looking for negative because it said less than or equal to 0. Yes. I knew what you were going to say, but the infinity, remember, is still. No. Okay. All right.